All right, good evening, everybody, and welcome to another webinar on the CodeVita series. And we will keep doing more and more of these webinars as we get closer to the CodeVita. Before I start, just two quick things. First of all, thank you so much for being on this webinar. I know a great match is going on, and I too hope that India wins. But we are going to conduct this webinar really quickly, and then I'm sure we can all go back to watching the match. So thank you all for being online when something like this is going on. That's the first part. Um, and yeah, so we'll get started right now on this webinar of CodeVita. The other announcement that I wanted to make was the last date of registration for CodeVita is the 24th of June, which is day after tomorrow. So that is on Monday. So please make sure that you register before that if you have not already registered. If you have already registered, then that's good. If you have not registered, please go and register. Those who have registered, I hope you have tried to do at least Mock Vita 1 or Mock Vita 2. They are sample questions on what kind of questions you can expect in Code Vita. So these are the two announcements from my side, and without much delay, let's go quickly into the topic of today's webinar. And I'm just going to talk a little bit about what the problem is firstly, and then we'll go into what exactly we should be expecting from it. So this is the topic for today, and the name of the problem is Chakravyuha. And so the really interesting thing about this problem is that it's a 2D array problem. So far, we have covered the topics of calculations, where we did the bank compare problem. In the first webinar, we saw some of the basic problems of maths. So that was that question called Stone Game 1-4. We have done that before. We also did a question based on arrays that was in the previous webinar, and that was called min product array. And today we are going to look at a question based on 2D arrays, which is the question we have right now, which is Chakravyuha. And the main thing to note here is, unlike the other questions, that is unlike Stone Game or Bank Compare or Min Product Array, when you come to 2D arrays, things begin to change a little bit. While there is some logic in 2D arrays, what any contest is going to test you on is going to be your ability to manipulate the array. How can you keep going around the array or inside the array, or take the diagonal of the array, or take the loop of the array, the row of the array? So those are the kind of things that any contest generally is looking for when they are testing for 2D arrays. So you will see that in today's session, where how 2D arrays actually plays out and how you can do some of the questions on 2D arrays. And again, just before I start, make sure you say hi on the chat so that my team knows that you're online, and we'd love to interact with you. So my team is online, they would love to say hi to you. So please say hi. Make sure you subscribe to the channel and like this video so that more people come to know about this video. All right, so let's go into the question of Chakravyuha, and let's just even begin by seeing what the question is. Now again, as I say with all of the questions, make sure that you first read the question fully. In fact, if you read the question on the Edyst platform, which we have kept on there, it's a very long question. So I'm not going to repeat that question fully over here because it's really long and I don't want to repeat the entire thing. But let me share with you a small version of what that question is actually saying. And the question says, if you have an input like this, all right, and don't worry about the entire thing, we'll come to it one by one. But if you have an input like 5, right, so let's say this is your input. This is one of the rare questions where you're not really given your number of test cases, you're just given an input and you're supposed to give an output. So given an input, there are two things that you need to print out. The first thing is this array over here, and we'll come to this array in just a bit. And the second thing that you need to print out is the number of power points and the coordinates of those power points. Now you might be thinking, whoa, what is going on over here, right? What is this array? What are the power points? We'll come to each one of them in a bit. So what exactly is this array? Well, if you look at the array closely, what you can understand is that the array is being constructed, it is of size 5 by 5. That is, if you have an input of size n, then you're supposed to create an array of size n cross n. That's what you're supposed to do, and that's what we have over here. It's a 5 cross 5 2D array, right? Now, not only are we supposed to create a 5 cross 5 2D array, we are supposed to make sure that the array is somewhat of this format. 1, 2, 3, 4, 5. That's all good. Then 6 doesn't start from the next row, but 6 goes down over here. So it starts over here. Then 7 goes down over here, and then 8, 9, and then we go this route. 10, 11, 12, 13, 13, then 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then finally we end up with 25. All right. So if you look at how this thing actually plays out, let me just show you the actual question. Just shifting to the actual question in just a bit. Okay. So if you look at the actual question over here, this is the sort of pattern that you'll get, hence the Chakravyuha, like it's going in a spiral inside. So what we are supposed to do is, in the 2D array, get this sort of a look, or this sort of a pattern. So again, just shifting back to the slides over here. Okay, one second. And, yeah, so just going back to the slides here. So what we have is nothing but this input, which is the input that is n, and we're supposed to create an n by n 2D array. And in that we're supposed to start from 0, 0, and then go all the way, fill up the first row, fill up the last column, fill up the last row, fill up the first column, then move on into a smaller square and do the same thing. All right, so let's just even begin and see how we're even going to start this question. Uh, we'll just give me about a minute, and then we'll come to explaining what the total PowerPoints means and what the coordinates mean in just a bit. All right, so if you look at the question, what we saw here is we need to create an n by n 2D array, and in that array we are going to start filling it one by one as 1, 2, 3, 4, 5, and then the next one is 6, 7, 8, 9, and so on, and then we'll keep going over here. So that's what the output says. The other thing that they want us to do is print the PowerPoints. So what exactly is a PowerPoint? A PowerPoint is nothing but the first element is always by default considered to be a PowerPoint. So 0, 0, which is nothing but this 0, 0 is always a PowerPoint. So that is, even if let's say input was 1 and we'd have just one element, we would have a PowerPoint 0, 0. Then all the other PowerPoints are the ones that are divisible by 11. So we have over here one PowerPoint 11, another PowerPoint 22. The coordinates of 11 are the coordinates of 11 is 4, 2. So 4, 2 is the coordinate of 11, and 3, 2 is the coordinate of 22. Right? So we have in total 3 PowerPoints. 0, 0, which is the first one, is by default always a PowerPoint. Then after that, all of the multiples of 11 are also PowerPoints. Now, if you just notice here, and if you take a pause, this question can actually be divided into already 2 parts. The first part is to actually generate this array that we have over here. So we can call this as the first part. And the second part is to generate the PowerPoints, or to find out the PowerPoints. Each of these questions in itself can be another question. But like I have been saying continuously throughout the series, CodeVita likes to mix up different concepts, and they like to bring those concepts together. Now, in this particular question, not only do you have to generate a spiral matrix, which is a very famous problem, but also while generating the spiral matrix, you're supposed to find out something called PowerPoints. Okay. So we'll look at both of them, and finding the PowerPoints is really within finding the spiral matrix. So once we finish doing the spiral matrix, finding the PowerPoints will not really be that difficult. All right. So before we even start, how do we even create, or how do we even go about making a spiral matrix, or what I would call this as a chakra? How do we go and make this a chakra? How do we generate a chakra over here? What you can see, and one of the approach that we're going to take here is, we'll look at it square by square. So that is, in this case, if you consider this as the outer square, that is this square, then you have another inner square over here, and finally you just have with one square left, right? Or in other words, if I just color it out over here, all of the different squares, I have one outer square over here, one inner square, and then one here. So I have totally 3 squares. How do we get the number of squares? We'll come to that in just a bit. But if we divide our problem of generating the chakra or the spiral matrix as a problem of first generating the outer square. So 1, 2, 3, 4, 5, that is 1, 2, 3, 4, 5, 6, 7, and so on. Then once we generate this part, then we'll start again and we'll start generating the spiral till over here, and then finally we just need to fill in this square. So if we divide the problem like this, it becomes a little bit easier for us. So let's look at what is till now, whatever we have discussed so far, what really is our approach so far. So just let's have a look at that. The first thing that we have to do is to create an array, and we'll calculate the power points. And I'll just tell you why we are doing this in the first step in just a bit. So just hold over here. Creating an array is pretty simple. This is going to be an n cross n array. So creating an n cross n array, it will be pretty simple for us. Then after that, we'll maintain a counter for the numbers. Why do we need to maintain a counter for the numbers? Well, generally, if we were doing a normal 2D array, then the row number and the row number and the column numbers would be really sequential. For example, you would have 1, 2, 3, 4, 5. You would have 6 from here. So that would be really sequential for us. But what's happening now is we have a custom numbering. That is, we want to decide when we are going to increase which number or which counter. So we have to keep track of the counter. We can't expect some for loop or while loop to keep track of how much or what is the value that is going to be there at each element. And this will become clearer when we actually do the code. So maintain a counter for each of the numbers. Then print each square separately or generate each square separately. As I had said, do the outer square, then inner square, and then inner square till finally you get to the final element. And when we are inserting the numbers into the array, then you check for the power point and store them. So this we'll do after we've actually done the code for printing the square. So we'll do it that time and it will become clearer to you. So for now, I'm just parking or keeping the PowerPoint thing to the side. Coming back to the first point, why should we calculate the power points in the first iteration itself or the first step itself? Well, it's not too difficult to calculate the number of power points. If I just go back to what were my power points, if you look at it, I have about 3 power points here. Well, my one power point is always going to be there. So I'll definitely always have at least one power point. So if I just go here, there is one power point for sure. After that, how many more power points am I going to have? And if you think of it, the answer is really simple. It is nothing but n divided by 11. For example, sorry, not n divided by 11, n square divided by 11. For example, 5 is going to have how many numbers over here? The total number of numbers that are going to fit into this is going to be 25. Now 25 divided by 11 is 2 when you consider it in terms of integers. So the total number of power points over here is 1 plus 25 divided by 11, which is 1 plus 2, which is 3. So we have 3 power points over here. Similarly, for any number, let's say we had the input as 10, we would have 100 numbers. How many multiples of 11 would be there in 100 numbers? And you just divide that by 11. I think that would be just about 9 numbers. 9 plus 1, that is the one power point we have. So we'll have totally 10 power points. So that's not too difficult to figure out how many power points we are actually going to have. So hence I said that let's keep that as the first step, that calculating power points. This is nothing but very simply 1 plus n square divided by 11. So, and n square is here. So 1 plus n square divided by 11, 1 is by default, and n square divided by 11 will get us the number of power points. So these two are, the first step is really easy and I'm sure we'll be able to do it. So I'm just going to tick that off. The second step, maintaining a counter for numbers, we'll come to that. Now printing each square separately. There is another question over here which I'm sure you must be thinking of. How many squares should we be printing? Like, we understand that we want to print each square separately, all right? We have to print each of these separately, but really how many squares will we end up printing? For example, for 5, it looks like this. But for 6, we have again the same number of squares. It's just that the dimensions of the squares are changing. For example, in 5, we had one full square, that is over here, one square here, another square here, and the third square was just of one element. But if you look at for 6, we still have 3 squares, 1, 2, 3, but the third square is really the same, it's not the same size as the previous one. That is, it actually has 4 elements in that square. It's not just one element. So how many squares will there be? And this is one of the places where I really ask you to take a piece of paper, take pen, and really take about 4 or 5 examples and see. What you will realize is that for all the even numbers, you're always going to have a square like this. That is, the last square is always going to be a 2 cross 2 square. The last square. This, for all the even numbers, this will be the case. For all the odd numbers, the last square will always be a 1 cross 1 square. So what we have to do is we have to make sure that to calculate the number of squares, what we can simply do is do n divided by 2. Because for 5 divided by 2, we still had about 2 squares plus that one element. For 6 divided by 2, we had 3 squares. So when we have an odd number, what we'll have is 2 full squares and just one element to print, and we'll take care of that one element after we are done with generating everything. So what we'll essentially have is, when we do it for 5, we'll do 5 divided by 2, which is equal to 2 in integers. And so what we'll do is we'll print the first one, we'll print the second one, and this square, we know that it's only going to have one element left. And which element will that be? It will be nothing but 25. That is, the last element is going to be n square. So for odd numbers, we'll just print one more element right in the middle. And for the even numbers, what we'll do is we'll keep printing 3 squares. We don't need to print an extra element. So I hope you understood that. If you didn't, just take a pause over here and take about 3-4 different elements, 3-4 different sizes of n, and see how you can actually do this by yourself and see what are the different squares that are coming. All right. So now that we know the number of squares, what we have to do is we are going to decide in each square what are the steps that we are going to do. So even in this square, we very easily said, yeah, we'll first print the first square, then the second square, and then the third square. But what does it really mean to print the first square and second square and third square? Well, the way we are going to print each square is by first printing the first row, that is, we'll print till over here. Then we'll print the last column just till here. Then we'll print the last row all the way till here, these elements. And then we'll print the last, the first column, sorry, all the way till here, because this part we had already printed. So at any given square, we'll first print the first row, that is nothing but the top row. Then we'll print the last column. Then we'll print the bottom row, and then we'll print the first column. And we do the same thing over here, over here, over here, and then over here. And the same thing over here, it's nothing but printing this element, this element, this element, and this element, right? So that is how we are actually going to divide and actually print these squares. And so looking at the approach for that, let me just see now how our approach has updated. Our approach is like this. First, we created the array and calculated the power points. That's simple. The array is nothing but an n by n array. The number of power points is nothing but 1 plus n square divided by 11, right? So that's really our number of power points. Maintain a counter for the numbers. We will do that. We will start from 1 and we will keep updating the counter from 1, 2, 3 all the way up to whatever it is, 25, which is again n square. All the way up till there, we'll keep maintaining a counter. Now for n by 2 squares, that is for all n by 2 squares, we have to print the top row first, then the right column, then the bottom row, and then the left column, which is nothing but top row, right column, bottom row, and then the left column. So like this, we are kind of printing the perimeter of that square. And then when we are inserting the numbers, we'll check for the PowerPoint and store them. So this part will come to right after this. What I'm going to do as a different thing in this tutorial as compared to the last tutorials is I'm going to go into the code right now. Ideally, you should write a little bit more pseudocode and go into it. But with 2D array problems, what generally happens is they are a little bit complicated, as in the sense that they are very implementation heavy. There's a lot of code. So instead of writing the pseudocode here, I won't bore you with that. Let me go directly into the code by looking at this approach that we have written so far. So let me just shift to my IDE and then show you how we are actually going to write the code for it. So I'm just bringing up my IDE. Just give me a minute. Okay. All right. And as I've said previously, I use an IDE called IntelliJ IDE, but you are free to use whichever IDE that you want. This IntelliJ IDE I code in Java, but again, it's up to you whichever language you want to do. Python is completely acceptable, so is C, so is C++, and any other really platforms or any other coding questions that you want to do, you do it in any other language. There is no restriction on the language. I am personally doing it in Java because of late I've just become comfortable in Java, but you can do it really in any other programming language. So without further delay, let's just get into this question. So the first thing, the simplest things is actually take the scanner, and so the scanner is needed to actually take input. So I'll just do that, and this is very standard in Java. In your own languages, you'll have your own standard things that you're going to write. One of the important things that we are going to do here is, since this is again a 2D array question and we're going to have to write again and again, that is, we're going to have to go through an array again and again, we might want to see what really is, one second, what really is the output at every given time. So what I'll do is, what I have really prepared with me already is a code that outputs the 2D array given a 2D array to it. That is, it takes as a function, it's a function that takes as parameter a 2D array and prints that 2D array. And I'm just going to paste it here. And I really want to show you this because this is one of the codes that I have with me, that I have already present with me, and that is very useful to me whenever I'm going to do any of the contests. To you also, I suggest that you keep such codes ready. It's always good to already be ready with such things. You don't want to write again how to print a 2D array again and again. So this is my code that prints a 2D array. All right. So that's what this one is going to do. So now quickly what we have to do is the first line of input is n, which is nothing but the size of the 2D array. So let's just take that as input, and we have that over here. So once you've taken that as input, what's the next thing that we're supposed to do? We're supposed to actually create the array, and let me just call that as chakra. So we're supposed to create the array over here is equal to new int. The size would be n by n. So this is how we do it. Again, this is how you do it in Java. I know in C you're supposed to do malloc and everything. So please stick to the syntax of your own language and see that how that works out. We also know if we just want to calculate the power points. So int power points is equal to, and what was it really equal to? 1 is the default. After that it would be n square. So that is n into n divided by 11. Those are the number of power points. All right. We'll come to the remaining part later. We need a counter, and the counter starts with 1. We will come back to PowerPoint soon. Come back to this. So we'll come back to this in just a bit. Counter starts from 1, and we'll actually we'll start counting once we start the loop. Now what I'm going to do is, if we remember what we are supposed to do, we are supposed to print the first square, the second square, and the third square, and so on. So what we'll do is, we'll actually open up a loop that tells us on which square we are. Okay, and what we're going to do is, that will go from I is equal to 0 till n by 2, because this will go for the number of squares. So it's going to count the number of squares. So we have to run n by 2 times, because that's how many squares we have. All right. Now pay close attention, because this is where things will start to get a little bit tricky. What we'll do is, we'll start by printing the first row. That's it. We'll start by printing the first row. And the way we are going to do that is, we are going to use a counter called row and a counter called column, and these are going to tell us which row and which column we are on currently. The other thing that they're going to do is we are going to define another thing called int end row, which is equal to 0, and int end underscore column. And the reason we are doing this is these two variables. So let me just put a comment over there so we all know what they're doing. This is the current row and column, and they're both 0 because we have to start from 0. That is, we have to start and print the first element. The end row and the end column tell us till how far we are going to go, ending of the current loop or the current printing. And let me just tell you what that actually means. Going back to my slides, let me tell you about that. So if you look at it over here, so if you look at, let's say this is our array, let's say it's a 5 by 5, sorry, a 6 by 6. We are going to start from 0, 0, and we're going to end at 0, 4. So at any given point, to note what is going to be our end, we have used end row and end column. Similarly over here, we're going to start at 0, 5, and to note where we are actually going to end, that is 4, 5, we have used a variable called end row and end column. So that's really the purpose of those two variables. So coming back to the code, okay, yeah, so there we are. So that's what those two variables are going to do for us. And if I'm going too fast, or if you have any doubts, please feel free to write anything on the chat. My team is listening, and I'll be happy to address your questions towards the end of this session. All right, so when we begin, that is, we are beginning at 0. So what we're going to do is we're going to make both of these as I. Now, what is the fun part over here is when I becomes 1, this will also be correct. Because if you notice, we always start from either 0, 0 or 1, 1 or 2, 2. So just bringing back my slides so that you understand, we always start at either 0, 0, 0, 0 or 1, 1 or 2, 2. We are always starting at I, comma I. So row equal to I and column equal to I is really what we should be starting with. All right, so just bringing up IntelliJ, yeah. Okay, so yeah, so that is what we should be starting with, which is row equal to I and column is equal to I. And let's first print the first row. Now in our first row, what is the ending column? Because the column in the first row, the row is going to be constant, that is, the row is going to be the 0th row, but the column is going to be the end column. So it's going to be not the last column but the second last column, which is nothing but, for us, if n is 5, it's going to be 4. If n is 6, it's going to be 5. So if you look at it, it's nothing but n minus I minus 1. Why is that? When it's the first square, it is n minus 0 minus 1. When it's the second square, it's n minus 1 minus 1, and so on. So it's the ending row, or the ending column rather, is continuously decreasing. So we'll take the ending column to be n minus I minus 1, and then what we'll try to do is we'll try to actually print this entire column. So the way we'll do this is we'll run a while loop, while column less than end underscore column. We will do we have to go through the entire thing. So what we're going to do is column plus plus, so that is, it's going to keep increasing the column. Now it's not just about increasing the column, we have to actually insert a value over there. So what is the value that we're going to insert? At chakra row column, we are going to include the value of counter, and then once you've included the value of counter, we do a counter plus plus. Just note this part, that later on we are going to come to this specific thing, and we are going to check what is the value of counter, is it a PowerPoint or not. So we'll be coming to that in just a bit, right? So this is really what is going to do, and it's going to print the top row. Now just to pause over here, let's just have a look and just pause over here just to see if you're going on the right track. let me actually output the array and see what it looks like. So this is a good way of debugging or just seeing if are we really on the right track by let's just output the array and see if we are going correctly. And so let's see what the output is so far. Right. All right. So by looking at for the output, what we need to do is we need to actually give the correct input. Let's just give us the input 5. I've given the input 5. So what it prints is 1, 2, 3, 4. It doesn't print anything after that. Then it prints 5, 6, and that's it. So what we can see is, let me run this again and let me do it for 6. What we can see is 1, 2, 3, 4, 5, 6, 7, 8, and then 9. All right, so we can really see that our rows are printing correctly. That is, the first row printed till here, that's correct. The second row printed till here, that's correct. And the third row printed here. Brilliant. So our first row is printing correctly. Similarly, let's try to print the last column. Now in the last column, what is going to change? The column is going to remain constant, but it's the row that is going to change. So what we have to do is, while row is less than end underscore row, but what really is the value of end underscore row over here? Again, end underscore row is nothing but n minus I minus 1. And so while row is less than end underscore row, we are going to do again chakra row column is equal to counter, and then we'll do counter plus plus because we have to increase the counter, and then we'll do row plus plus because we have to change the row. We have to come down like this, so we have to actually change the row. Now let me again take the output and see how much and how what is really the output at this point. So let's see how it's running. So let's say if I do 6. Okay, very interesting. So I have filled the first row, it's filled the last column as well, it's filled the second row and the second column. Obviously, after the first row and first column, the values are not correct, like it's giving 11, 12, 13 over here because the counter value is not correct at that point. It should start with 11, 12, 13 over here, but we are going in the right direction. So let's again with the same motive, let's do this. Let's now again what we have to do is again print the last. So we printed the first row, printed the last column. Let's print the last row. To print the last row, we have to do end underscore row is nothing but I. That is, in the first iteration, it has to go all the way back to the first column. In the second iteration, it should go to the second column. So this would be not end underscore row, but end underscore column, and we'll make it I. And then let's run a loop again. Over here columns are going to change. So while column is greater than, because now the column is already to the last, we want to bring it back. So while column is greater than end underscore column, we take chakra of row column is equal to counter, and counter minus minus, sorry, not counter minus minus, counter plus plus. We have to always increase the counter, but it will be column minus minus. That is, we are taking the column back over here. Again, as we were doing, let me just leave a comment for each of these. So the comment over here was that this is printing top row, then the comment printing last column, and then over here is printing last row. All right, let's just take the output again and see if our output is coming correctly as we had hoped for. So for an input 6, let's see how it's going. Okay, for input 6, we have the output 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, then 12, 13, 14, 15. Brilliant. So we are really going on track. The only thing we are left to do right now is to write the last row, the last thing that we're supposed to do is write the first column. So to print the first column, let's just look at how we had done the column over here, which was nothing but this. So I'll just copy paste that and just change some of the values. In this case, to print the last column, the column remains constant, the row is the one that is changing. So the end row is nothing but I, and after that, while row is greater than n underscore row, we'll print chakra row column is equal to counter, counter plus plus, and row minus minus, because we're taking row back. All right, now let's just run this, and this should run and give us the correct answer. So let's just see for 6. Yeah, so I'm just running it for 6. And yes, we get the correct answer over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. So you can see that it's going in the absolutely correct direction. The only thing that we've missed out is, if you remember, for odd cases, we won't get the correct answer. And let's see how that's looking like. So for the odd cases, let us put, let's say something like 5. What's the output that we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, all is good. But in the middle, we got something like 0. Why did we get 0 over here? Because we never really went to the last element. So let's just go back and understand how we can really end up printing the last element. And just coming back over here, what we had said was initially that we'll print the first. So for 5, what we did was we printed the first square, which we did correctly. We printed the second square, we did that correctly, but we didn't do anything for the third square because we never really considered it. We did it only for 2 iterations. Well, if you look at it, for any of the odd numbers, what's going to happen is we're going to get one element. What is the value that is going to be at this element? So the value is going to be n square. That is the last one. In this case, it's 25. In the case of 6 or 7, it will be 49. In the case of 9, it will be 81. But the last value is going to be n square. So all we have to do is, for this last element, we just have to update it with the value of n square. And what is the index of this element? The index, if you notice, is always right in the center of the matrix. That is, it's in the exact center row and center column. So the center row and center column are nothing but n by 2 comma n by 2. So the center row and center column will have this value, which is n square. So let's just update that in our chakra code, and we'll be done with at least generating the chakra code. So let us just update that over here, which is, once all of these things are done, that is, once the loop has been completed, this was the loop that was generating it. So let's say once this loop is completed, let me just minimize it. Once this loop is completed, what we're going to do is we're going to do if n mod 2 is equal to 1, right, which is nothing but in the case of odd, then what we have to do is we have to do n chakra of n by 2 comma n by 2 is equal to n into n, which is n square. Now notice one thing. The beauty of this code is that even for the edge case, and the edge case is that the input is just 1, in that edge case, it will completely skip this loop. Why? It will skip this loop because n by 2 would be 0. It would not even enter this loop. So it will skip this loop. It will say that this condition is correct, and n by 2 and n by 2 for n equal to 1 is 0. So the answer would be 1. So with this condition, we also take care of the input that n is equal to 1. Alright, so now that we have updated it, let's just look at those two cases where n is equal to 1 and n is equal to 5, and let's see how it comes out. Are we getting the correct answer or not? So n is equal to 5. Yes, 25 is in the middle, so that's correct. Let's again run it, and let's look at the edge case of n is equal to 1. So for n is equal to 1, 1 is the answer. So we've done the first part correctly. If you want to pause, you can pause here right now and just go through what we've done. The first part has been correctly done, that is generating the Chakravyuha or the chakra matrix, the spiral matrix, whatever you want to call it. The first part is done. So I hope you followed it so far. The next part is actually fairly simple. So let's just go back and see what really was the next part. So as per the question, the next part was nothing but, given the input over here, we have so given the input over here, we have to print the total power points. That is, whenever so your 1 is your default PowerPoint, but also we have to take 11 and 22 as the PowerPoints, because they are what you could call a um, divisors of they're multiples of 11. So whichever are the multiples of 11 are the PowerPoints, and we have to note them in something called as the coordinates. So we have to take 0 0 because that's the first PowerPoint, 4 2 is 11, and 3 2 is the next PowerPoint, and we have to print it exactly in this order, that is in ascending order. That is, first we have to print 1, then we have to print for 11, then we have to print for 22. Okay, how do we go about doing this? Well, the way we'll do this is we'll generate another array. Let's say we take another array over here, right? And it's going to consist of all of the XY coordinates of our PowerPoints. So what we have is the first one is going to be 0 0 because that is the first PowerPoint. Then what we'll do is we'll take 4 2 over here, then we'll take 3 2 over here. The reason we want to do it like this is we'll always have two coordinates for each PowerPoint. So we'll take an array and we'll store, this is the coordinates of the first PowerPoint, coordinates of second PowerPoint, coordinates of the third PowerPoint. Now to create this array, what will be the size of this array? The size of this array would be 2 into the PowerPoints. Why? Because each PowerPoint is going to have two coordinates, and we are going to have PowerPoints, number of PowerPoints. So we need 2 into PowerPoints number of coordinates. That is going to be the list size. That's really about it. Once we generate this list, all we have to do is print the number of PowerPoints and then print the elements of this list or this array. So let's go about doing that. Okay, so I'll just shift back over here and I get right. So what's the first thing we're supposed to do? We are supposed to calculate the number of PowerPoints which we have done and which we written. We come back to this. We're back, right? So now that we've written the number of PowerPoints, let's take an array which will consist of the PowerPoints list. So let me just call it pp underscore list, which is the number of PowerPoints, and its size is going to be 2 into the number of PowerPoints. All right, so that's how many PowerPoints, that's the size of the PowerPoint list. And also, without even doing anything, we know that the first two coordinates are 0, 0. So we know the first two coordinates are 0, 0. So let's just initialize it like that. This is for the first PowerPoint. All right. So now why is this giving us a certain error? All right. So it says pp list is equal. Okay, I put two equal to's. My bad. Anyways, so first PowerPoint is this. So this is the first PowerPoint. Now, whenever we come across a PowerPoint, how will we come to know we've come across a PowerPoint? We have to know if it's going to be divisible by 11 or not. And what is going to be divisible by 11? The counter. So here we have put a chakra row column is equal to counter. If counter mod 11 equal to 0, that is it's divisible by 11. In that case, what we do is pp underscore list of pp underscore list of something, we don't know which value it's going to be, of something is equal to row, and pp underscore list of something, we'll come back to that, is going to be equal to column. So as we realize, we have to maintain a count of how many PowerPoints we've actually come across, because the first one was 0 0. After that, what are the other PowerPoints? We have to take a track of that, and we don't know how many we've done so far. So the way we'll take track of that is through a PowerPoint counter. So pp underscore counter is equal to 2 at this point, because both 0 and 1 were 0. So we are currently at 2. So our pp underscore counter will be equal to row, and then the next one after that is going to be the column, and then we'll increase our pp counter by 2, right, plus 2. If you're confused about what just happened, let me just take a step back and tell you what we actually did. So what we've done is nothing but we're trying to create this array where we initially took the number of PowerPoints we had to be, like in this case, the number of PowerPoints we have is 3. We created an array of size 6. we took our the first two default elements to be 0 0, and then our pp counter was 2. The moment it came across 4 2, it made sure that 4 was stored in 2, 2 was stored in 3, and then it did 2 plus 2, which is 4, so that it's pointing over here, so it became 4 over here. So that's what we're doing. We're just updating the counter of our array so that we know how much or how many PowerPoints we've already come across. That's all that we're doing over here. And this is not just done for the first time that we're going to encounter a PowerPoint. We have to do it every time. So this condition really has to come up every time that we do it. So for when we print the first row or when we print the last column, similarly, similarly for the last row, and then for the first column. So every time that we're going to come across this, we have to do this bit. If counter mod 11 equal to 0, then we do this. All right. Okay. Are we missing anything? I don't think so. The only thing probably that we could be missing is if at this point, let's say if n into n is itself a PowerPoint. So at that point, actually, we ought to be doing, if n to n. Yeah. If this itself is a PowerPoint, which will only happen probably for really large numbers, like probably for 11 and then probably way later. So that's the only time that this could happen. So in any case, it's good to note this, that at this point it would be by 2 and by 2. So that's just the last thing that we have to consider. All right. So what is the output format like? So we were printing out the array as per just to check for debugging, but what does the output format actually say? And for this point, let us actually go to the coding and see what the output format is. So the question says that the output format has to be like this, and let me just zoom in so that we can all see. So first we have to print the n by n matrix depicting the placements of the army units, which have to be delimited by a \t tab. So I'll just go back and check if I've done that. So in my code I had done a \t. If you have not, please make sure you do a \t. Print the total number of power points collected, and print the coordinates. We have all of these things, so we can do that. The way we have to do it is this: total PowerPoints 3, and then all of these things. So let's just copy this so that into our code, so we know what exactly we have to print. So just going back to our code. Okay, so we have to print in really this format. Okay, so let's just do that. The first thing is obviously the output of the chakra that we did, and that was correct. Then after that we have to print system.out.println total. Actually, let me just copy that entire thing because I don't want to mess up any spellings. So let's copy it over here, paste it, and the only thing is over here we are supposed to print the PowerPoint. So that is this. Okay, and then after that we're supposed to print all of the PowerPoint. So that would be through a loop. We'll go through the entire PowerPoints list. That's pp list dot length. Okay, so we're traversing through the entire PowerPoints list, and at each point we have to take the coordinates and print it. So the way the coordinates are printed are like this. The first is a bracket, then the row, which would be pp underscore list of I, then a comma, right? Okay, there's a comma over there. Then again we have to print the column number, so that would be I plus 1. Okay, and after that what we have to do is print again another bracket. Okay, so the one thing over here is we are printing two elements at a time, so we should not do I plus plus, we should do I equals to I plus 2, because we're taking two elements at a time, so I should also skip 2 times. Okay, so let's just run this and see if we're getting the right output format, because in 2D arrays that's generally the problem. Output formats are really not that easy to get. Let's just run it and see for 6 what is the answer that we get. 6. Okay, so it says total PowerPoints 4 for 6. All right. Is that correct for 4? It's saying 5 comma 5 is a PowerPoint. Yes, 33 is a PowerPoint, so that looks correct. But let's go back to 5 because that's a answer that we are familiar with. So let me just print for 5 and see. Yeah, it says total PowerPoints are 3004232. Looks correct. Let me just take this code and see if it will run on the online compiler. So just going back to the online compiler, and here I go. Okay, right. The one thing whenever you're copying from an IDE to an online compiler is make sure that you comment out this part, that is package, com, company, whatever. There are no packages as such for these online compilers. So let me run it. Let me see, do we get anything? Okay, it says my test cases are passed. That's cool. So all right, let me try to submit it and see if it works. And okay, yes, all right, congratulations, you passed the test cases. So again, as I say with all of the times that we do this, don't think that you'll get it on your first attempt. It actually, I did this question a little bit before starting the webinar so that I at least had some practice with it. And the way I did it is exactly the way I told you. I first tried to generate the matrix because that was the toughest part. I knew that the PowerPoints was really going to be simple to do. So generating the matrix is the first thing I did. And always check that trick out, that keep an output array function ready, or any of these functions that are very, very simple to do. Keep them ready so that you don't have to waste time during CodeVita to come up with those functions. So again, just recapping on what all we have done so far. The main thing that we did was we created the array and calculated the PowerPoints. This was an n cross n array, if you remember, and we got a formula for PowerPoints as well. If you remember, just again saying it one last time, it's 1 by n square by 11 plus n square by 11. Maintain a counter for the numbers. We saw how to do that. Then we created 4 different loops for each of these. So there was, for each of these n by 2 squares, we started a loop for this one. We did a print top row, print right column, print bottom row, print left column. And if n is odd, then we printed the last number as well. That was the last thing we did. Finally, when we were inserting numbers, we checked for PowerPoint and stored them. Right, so that's what we did. That's a recap of what we've done so far, and a small trick that I've shared with you right now is keep some of these functions ready with you. You don't want to be creating these functions again in CodeVita. The one last thing that we didn't do for this problem was, did we check the constraints? If you check the constraints, n can be a maximum of 100. So that's fine with us because that can easily fit into an integer. In the last webinar, we had to use a integer or a data type called long. So that was a problem last time. So this is a summary of what we've done so far. This is where I will stop right now and go back to about question and answers. If anybody has any questions, any answers, I know there are some of you already have some question answers. My team is ready over here. Just before I go there, please make sure that if you have any questions, please type on the chat and I'll be more than happy to answer your questions. And also, just one last thing, make sure to subscribe to this channel so that you know of any other webinars that we're going to do. And please share with your friends, because I hope you found this session helpful, and I want you to share with your friends who might find it helpful as well. So let's go to the question answer sessions. So yes, please tell me what are the questions that we are getting right now.
So this is from a previous webinar.
Okay.
In previous webinar, you started with pseudocode. How important is a pseudocode?
Okay, all right. So in the previous webinar, just repeating the question, in the previous webinar, I had started with the pseudocode. So how important is the pseudocode? So it's a very good question, whoever's asked it. Pseudocode is very, very important. So even if you look at the approach that we did over here, we first started with constructing an approach. We didn't even start without that. So the first thing we did was actually create the approach over here without starting any question. Don't start with the code directly. Keep your editor open, keep your compiler open, whatever you have to do. But if you start coding directly, you will miss the edge cases. As we noticed over here, 1 is an edge case, odd numbers are an edge case. You will miss the edge cases and you will miss out the main logic. Don't start with the code, start with an approach. I didn't go into the detail of the pseudocode over here specifically because it is a 2D array question. If I went into a pseudocode of that and gave you a pseudocode for each of the loops, it would be a very long session. So I didn't want to bore you with that. But pseudocode is important no matter whichever code you do. Start with pseudocode and then only go into the actual code.
So, which language do you suggest to use?
Okay, so one question we've been asked is which language do you suggest to use? My answer to you is use the language you are most comfortable with. When I say most comfortable, when I show you a pseudocode, which is the language you are most easily able to translate into code? For me personally, that language is Java. The moment I see a pseudocode, I am able to very quickly turn it into Java code. That does not mean I don't know other languages. It's just Java is the most natural to me. Most of the students and most of freshers, especially all of my friends in core subjects, in your first year you have probably done only C or C++. CodeVita is just 2 weeks away. There is no time to learn another language, and CodeVita completely supports C and C++ also. So if you are already good at C and C++, just choose that. There is no need to choose any other language. Just choose the language you are comfortable with. There is no need to learn a new language because all of the languages are supported in CodeVita. And now is not the time to start learning a new language. So my answer is choose the language you are already comfortable in, that when you read the pseudocode that I have said, you are able to directly convert it into code without anything.
So, what are the common mistakes made by students in CodeVita?
Okay, a very, very good question that we've got here is what are the common mistakes that are made by students in CodeVita? Actually, the funny answer here is the most common mistakes that students make is that they are not able to take input properly. And what do I mean by this? Let me show you an example question by what I actually mean by that. So just opening up that question, just give me 2 seconds. Yeah. So if I open up a question of the free module of CodeVita that Edyst is offering, if you look at the free module completely, taking input is very, very difficult for people. So for example, even a simple question like this, input integers, that is the first line is nothing but the number of inputs, and then after that it is a list of integers and you have to print all of the integers. Now you might be thinking, hey, this is a very easy question and I can do this whenever. Have you actually done it? Because if you've not done it, I really suggest you go and implement this question. It's a very simple question to look at and it will probably take you only 10 minutes, but it should take you only 2 minutes, not 10 minutes. Many students I have seen who are very brilliant logically, who know everything in arrays, 2D arrays, recursion, backtracking, but because they didn't practice on how to take input, struggled for 30 minutes in getting the right input format. So the number one thing that students struggle in CodeVita is really about how to take input. So if nothing, I would suggest all of you to get on to the free module of Edyst. Don't even go to the other parts. At least do the free module and at least figure out how to take input in your specific language. With that practice, you will at least have a much better chance of clearing CodeVita.
Does using code from our own GitHub repositories will lead to plagiarism?
Okay, a very good question. Someone's asking if we use a code from our own GitHub repository, that is, if for those of you who don't know GitHub, if you are using a code that you yourself have written and you're just copy pasting that, is that really considered as plagiarism or as copying? So what is that considered as? Well, if you look at the official CodeVita response, they say that you can copy paste code from other places as long as you correctly attribute the code. What does that mean? Let's say I have a friend called Ramesh. I took some of the code written by him. I have to very correctly write a comment over there saying that this code has been taken from Ramesh so and so. If you mention that, then that is counted as attribution. It is not counted as plagiarism. However, will that attribution reduce your marks? We don't know. They have their own internal system of figuring out attribution, so we don't know that. Also, if you're attributing to yourself, you still have to write the comment. Just because it's your own code doesn't mean that you don't write the comment. You should write the comment that I have taken this code from so and so URL, so and so link, like github.com/ whatever is your link, and also mention that code is written by me. The reason is, let's say you get all the correct answers and you're called for an interview. In that interview, they'll pull up your code in front of you and say, can you explain this line? Can you explain this line? Can you explain this line? And if you actually have written over there that this was attributed to yourself or to someone else, then you can actually explain that, even though I had taken the code from somewhere else, I know the logic for it, and this is how I'll explain the logic. Now, how attributing will affect your marks, that we don't know. That is an internal process. So to the extent possible, please use your own code. There is really no need of copying from anybody else or taking from somewhere else. Right. Next question.
What is the timeline for mock vitas?
Okay, so someone's asking what's the timeline for mock vita. As far as I know, 2 mock vitas have already been done. I don't think they're going to do another mock vita because code vita starts soon. But 2 mock vitas have already been done, and that is actually a special announcement from us. We are going to be covering many of the mock vita questions in the upcoming few days on the Edyst platform. So stay tuned for that. Please log on and register on the Edyst platform. And just on that note, what I also wanted to show everybody is really, if you're still hesitant and you're still not started practicing on CodeVita, I just wanted to show you that on the Edyst platform, at least, there are a lot of serious people and they're just going at it. In fact, if I can just open that up right now. Yeah, so this is what the platform looks like. If you look at it, even till about 1 hour and about 2 hours ago, people were writing all sorts of code. If you look at the leaderboard, people have finished up to, I don't know, about 20, 30, sorry. See, this person, for example, Som and Monisha are doing really well. They've finished about, I think, 20, 30 questions already of the 80 questions that are there on CodeVita. So really, I will suggest to you that don't miss out. Don't wait till the last day. Your friends, your batchmates, your competitors have already started coding and they're going great. If you look at the number of people, I don't even know how many have signed up right now. Like, it's just going on and on and on. I think it's roughly about 500 people are already on the platform, started practicing. Don't lose out on the thing. We have this concept of streaks also. There is Sai Sri Turga. She's been online and practicing continuously for 10 days. So for the past 10 days, she's been continuously practicing Code Vita questions. Don't lose out. If you have not yet signed up on the platform, sign soon. All right. Yeah, any other questions?
Yes, I mean, you want to make any announcement?
All right, so I think that's the end of the questions. Thank you so much, everybody, for joining. I don't have any other announcements apart from stay tuned for mock Vita questions. We're going to have some amazing mock Vita questions coming soon. We've already launched some of the new tutorials on the Edyst platform, so please make sure that you do that.
One more
And
question.
we have one more question, it seems. So I'll just stop myself and then listen to the question. Yes, please.
Does presentation error mean that our solution is fully accepted?
Does?
I mean, presentation error mean?
So presentation error, does it mean that our solution has been fully accepted? I am not yet familiar with presentation error. I think it is as part of the TCS platform. Let me look that up for you, and we'll get back to you on that. What I would suggest is, if you can see the email ID below, if you can just send that query to us exactly. Probably if you have a screenshot of that, send it to us. We'll be more than happy to look into what that means. So what that presentation error means. So team@edyst.com, or you can just WhatsApp us that screenshot and we'll be happy to take a look at it. Right. So I think that's the last question. So just 2 announcements. One, a lot of mock Vita questions coming up, and the other thing that we want you all to do is make sure that you practice a lot on the platform. The one thing we are going to do is we are going to change the timing of the webinar. A lot of you have requested that the webinar should be held at 6:30 p.m. or about 7 p.m. so that you get a chance to actually be online and come back from college and actually attend. So we are going to change the timing soon, so stay tuned for that. And as always, please like this video and please share it and subscribe so that more and more people can benefit from it, because these are solutions to previous code vita questions. These are completely free on YouTube. Make sure that your friends at least benefit from it. It will be really helpful for them. For any other queries, any other doubts, 2 things you can do. Number one, WhatsApp us on this number, call us on this number, or email us on this number, on this email ID. Or 2, just come online on the Edyst platform and I am online and I can chat with you. So right, so should we wrap up? Should I wrap up? Okay. All right. Thank you everybody for being online. Um, I know it's a match day. I hope we win the match. And I hope you all go and support India, and let's see us winning the match right now. So all the best, everybody, for the Code Vita preparation and also for the match today. Thank you so much for being online, and see you in the next webinar. Bye bye.